Measurement for class 11. Measurement. Let us go with an example. The length of the room equals 4 meter. It can be written in centimeter. So 4 meter equals 400 centimeter. So here, to measure the physical quantity length, we use two parts. One is the numerical part. The second one is the unit part. When unit part become less, the numerical part become more. So we can say that in general, Q equals N times U. N is the numerical value, U is the unit section of the physical quantity in measurement. So smaller the size of the unit, then larger the numerical value. On the other hand, larger the size of the unit, then smaller the numerical value. So Q equals N1 U1 equals N2 U2. This equation, once again, we use in dimension. Instead of U1, we use dimensional formula. So measurement of a physical quantity equals the numerical value of the physical quantity into size of the unit. We have to remember it again. Let me read it again. Measurement of a physical quantity equals numerical value of a physical quantity into size of the unit. So I can say that measurement, the comparison of any physical quantity with its standard unit is known as measurement. The comparison of any physical quantity with its standard unit is known as measurement. So U is the standard unit. This standard unit divides Q, then you get N. N is the number of times this U get repeated. So let me go further. Physical quantity. So here there are certain example: length, mass, time, force, energy. So look at each term can be measured. So the very important common property of all these terms are they can be measured. So the first point is physical quantity can be measured. Whatever you measure, it is a physical quantity. This is the first foremost important point of a physical quantity. The another point is much more important. So let me read this. So this physical quantity in terms of which the laws of physics are described. So let me go with a simple example. F equals ma. F equals ma. This is a simple formula in physics. If you apply F equal to 1 Newton and the quantity of mass which takes an acceleration of 1 meter per second square, then I can clearly say that the mass, the amount of mass, the amount of substance that we call it as mass, in this example, definitely equal to 1 kg. So this kind of relation is possible only when you define what is mass exactly, right? And what is length exactly, what is time exactly. So that has to be followed worldwide without any change from one country to from one person to another person. So there are two things here, very important. Let me read it again. Physical quantity can be measured. That is the first point with which we can describe all the laws of physics. Thereby we can understand the nature. So how nature works. We can even predict an event with the help of the physical quantity. Physical quantity are of two types. One is the fundamental quantity. The second one is the derived quantities. So fundamental quantity. So example, so length. This length cannot be measured from mass. Mass cannot be measured from length. So time cannot be measured from mass. It cannot be measured from length. The same way, the one quantity in this section cannot be measured with the help of the rest of the section. Like that, it goes. Temperature, it's an independent physical quantity. Electrical current, which quantity quantity. Then you have luminous intensity, which is an independent quantity, and the quantity of matter. And these seven quantity, these are all the basic quantity. They are totally independent quantity. They never depend upon any other physical quantity. Such special type of unique physical quantity, we give a name it is fundamental quantity. Let me say the definition. Quantities which cannot be expressed, expressed in terms of any other physical quantity. Quantities which cannot be expressed in terms of any other physical quantities are called fundamental quantities. So derived quantities. Look at here, there are example, volume. To find the volume, we need 3 times length, one along the x-axis, one along the y-axis, one along the z-axis. If you know the length in these 3 axes, then only we can able to find the volume of a given object. So like that, area. To find the area, so you need any 2 axes, okay, either xy or yz or zx length to find the plane, the area of the plane. So you need 2 times the length to find the area. The third one is the density. It is mass per volume. So these physical quantity, what I have given here, depends more than one fundamental quantity. So these quantities are called as derived quantities, quantities which can be expressed in terms of fundamental quantities. So look at the plural form. Quantities which can be expressed in terms of fundamental quantities are called derived quantities. Unit. So here we have given an example, 10 meter. So in 10 meter, one is the numerical part, the other part is the unit part. The meter is repeated how many times? 10 times. Okay. If we know what is exact length of 1 meter, definitely we will know. So what is the length of 10 meter? So we can imagine, we can say correctly, this is what the length would be and all. So this is very good. So if you don't measure what is 1 unit of length, that is meter, then measuring the length will be different for different people. So it leads to a chaos, a big confusion. So here we need a standard reference to measure any physical quantity. That's what we call it as unit. A unit is a standard quantity. A unit is a standard quantity. A unit is a standard quantity with which the unknown quantities are compared. The unknown quantities are compared. So it is defined as the specific magnitude of a physical quantity that has been adopted by law or by convention. So it is the specific unit is a specific magnitude of a physical quantity that can be adopted by law or by convention. So in olden days we follow convention, but nowadays we define all fundamental units in terms of the property of atom. So it becomes fixed, okay? It never changes with the time. That's very important. In olden days, we follow a convention method, but right now we need to fix all the units of physical quantity, base quantities in terms of properties of atom. So unit. So characteristics of units. Let us read one by one. The first one, it should be well defined. Second one, it should be in convenient size. It should not be too big, it should not be too small, and it should not change with the time. So that's why we define the unit, the fundamental units in terms of property of atom. The third, it should be easily reproducible. So in any country, any man can easily reproduce this standard reference to measure his length and other things. The fourth one, the fifth one, it should be internationally accepted. Then only there will not be any kind of confusion among the countries in exchanging the scientific papers. So it should not be affected by external conditions like pressure, temperature, and all. Then the last one, it should be easily accessible. So these are all the important characteristics of units. So it should be easily accessible. It should not be affected by external conditions like pressure and temperature. It should be internationally accessible. It should be easily reproducible. It should not be changed with time. It should be in convenient size. It should be well defined. So let us go with the fundamental units. There are 7 fundamental units we have learned, each of them having their own unit. So mass has a standard reference. That's what we call it as kilogram. Length has a standard reference. That's we call it as meter. Likewise, time has second, current has ampere, temperature has Kelvin, amount of substance has mole, and the luminous intensity has candela. So let me read now what is fundamental units. The units used to measure the fundamental quantities are called fundamental units. The units used to measure the fundamental quantities are called the fundamental units. So let us next go to derived units. So look at these derived units. There are few derived units are given in this table column. Let me read area. Its unit is meter square. Volume, meter cube. Speed, meter per second. Mass density, it is kilogram per meter cube, and concentration, it is mole per meter cube. Mass concentration, that is kilogram per meter cube. So these are all the derived quantity. Let me now read what is a derived quantity is all about. The units used to measure the derived quantities are called, sorry, here I have made a mistake. The mistake is it is not fundamental units. This is derived units. So derived units. Derived units. Sorry for a little mistakes. Okay. Thank you.